Thanks again, everybody, for joining our special webinar. This time, not by QFS and about QF test, but about security concerns during application development. How did it come to this? Many of you may know last year QFS was acquired by MGM Technology Partners in Munich. It's now our mother company. It was a very good move for us. Things are working out very well. And in this process since then, well, we not only got a new mother, we also got a number of brother and sister companies. And one of them is the MGM Security Partners. And we've been in contact since, have exchanged a lot of ideas. And it's been extremely interesting to learn about their approach towards security. And since there were many questions during the past 20 years in the direction, well, QF tested does test automation. Do you also have solutions for security? Until last year, we didn't have a good answer, but now we do. Yeah, and this is what we wanted to tell you about, and that's why we have this special webinar. So I'll hand over to first Alois and then Bastian. Stage is yours.
Thank you very much, Gregor, for your kind introduction. Welcome, everybody. We are very pleased to have the opportunity to present ourselves here. So we'll do one slide about the company, and then we'll go into the details. We are MGM Security Partners. The company was founded in 1998, some 25 years ago. I have been with MGM for 23 years now. And similarly to QFS, we have been acquired by MGM Technology Partners 9 years ago. So we are part of the MGM group now. Our goal as MGM Security Partners is to help our companies, our customers, to develop applications securely. So we do that partly in-house within MGM. MGM develops enterprise solutions, for example, for the public sector or e-commerce solutions. And we are there to make sure that these applications are developed securely. But we have a large deal of customers ourselves, external customers, some of whom we have been serving for over 10 years, sometimes with large frame contracts. And we started out as a software house ourselves, so we have first-hand knowledge of software development. We know what we are talking about. Size-wise, we are about 50 employees, mainly located in Germany. We have offices here in Munich, Berlin, in Cologne, Dresden, and Leipzig, and we have an offshore location in Da Nang in Vietnam. So let's make a distinction first. When we talk about application security, this is a totally different story than talking about infrastructure security, which might be implemented by a firewall. And we have this picture here to help understand what is going on here. So our server, our VM that is hosting an application that we are talking about is symbolized by this city here in the picture. And that city is surrounded by city walls that stand for the firewall. And there is a horse cart coming with apples that represents the incoming traffic. So the browser request with form data that you're sending to your application here, let's say an online store. What the classical firewall cannot do is distinguish between traffic that is legitimate and traffic that is dangerous. So the firewall is making sure that gates are closed. Ports that are not used are being closed here, like port 25. But we need to have the gate 443 open to enable traffic to the destination. So the horse cart must get into the inner circle of that firewall to reach the destination. What the firewall cannot do is look into what the cart has loaded. So sticking to the picture, it cannot look into whether there are, let's say, rotten apples underneath the good ones, or whether it's too many apples on the cart, or whether there are melons among the apples and things like that. So it is the task of the application developers to make sure that the application reacts in a secure way, no matter what data is being delivered. So that's what the whole story is about today. And I want to have a second slide for some basic ideas. Many of you will know this kind of graph. It states the cost of bug fixing. The blue line is the number of defects that are being introduced in certain phases of the development cycle. So in the coding phase, most of the bugs are being introduced. The yellow line shows the number of bugs that are being found in that phase. Of course, during test phases, functional tests, system tests, most of the bugs are being found. And the last line, the blueberry one with the dollar signs attached, is the cost of fixing a bug during that phase. So it's very clear that if we try to fix bugs after we have done a final test just before going live, this is the priciest option we have. And this holds true for all the development methodologies you can think of, whether be it waterfall or cyclic approaches like agile approaches. They all follow that pattern. And this lays ground for some trends that we see in secure software development during the past few years, I would say. The first one is labeled shift left. Shift left simply means start early with testing. Do not only do a gateway test at the end, like a penetration test to make sure that you have reached your goals, but start with testing as early as possible. The reason is very simple, because you have reduced costs for fixing that bug in that phase. The second basic approach is security by design. So already when designing software, we are making sure that we consider security aspects, be it like technical aspects like input validation or the way we access data in the database, but also processes, for example, for a password reset. So we have to make sure that we do not introduce vulnerabilities there. We are convinced, a lot of other people are convinced, that you cannot introduce security by late testing. You cannot test security into something that is already ready, that is ready to be deployed. It's just like you cannot test in resilience or load behavior and things like that. Things like that have to be considered at a very early stage when you decide on architecture and things like that. And the third big issue is DevSecOps. It means when you look at modern life cycles of software development and deployment, we are in an environment where we deploy every 2 or 3 weeks, maybe even into production. That means we cannot do a full-scale manual test every 2 or 3 weeks, each time we put something into production. This is something that has to be integrated in the development cycle. And we have to make sure that all the skills that are necessary to do that deployment are involved. So the developers, security experts, and the operational personnel have to work together in a team. We have to avoid silos, and we must not see security as an appendage of software development. It's a joint responsibility for security on the application and execution environment level. All this together make sure that we have a smaller time to market. We are able to deploy something quicker. And of course, we have a quicker return of investment. So we will look into the software development lifecycle now in detail. And this picture here with the 8, and commonly known as the DevSecOps 8, shows many interaction points where we can get into the process with security tasks. The starting point for all that is a kickoff where we determine the basis, what is there in knowledge, processes, and rules and regulations and goals. What are we trying to achieve, and derive measures and milestones. So this is the 8 that I've talked about. This is the representation of the software development lifecycle with the different phases that you're all aware of probably. And the red bullets represent potential interaction points, touch points for security measures. We all start with the kickoff, as I said, determine where we start off, where we want to go to, and derive measures and milestones. And if we look at the different touch points for security measures, there's like two different sorts of interaction. The first one is what we have labeled analysis and support here. We are trying to lay ground for making sure that the development can happen in a secure manner. So we are providing training for developers, but also for non-technical staff. The training can be on a technical level. How do I implement certain features? But what is equally important is the awareness of developers to be drawn to attackers' methods. How do attackers think? How do they work? Because developers usually think in the way the application is designed to be used. Attackers are using the application in a totally different manner, and it's often important to have a different point of view onto your application. It can also be guidelines, coding guidelines, and things like that. And mostly and importantly, security experts being a part of a development team, become a member of a development team, and being with the team during the development process. And the other layer is the testing layer, or the level of interaction is the testing part, where we verify that what we have done beforehand has been successful. So could be a gateway, like a penetration test just before a major release, and it will be ongoing if you want to release regularly, nightly, weekly, or whatever, and that has to be an automated kind of test. And Bastian will go into much more detail on how we can implement those different kinds of tests. So at this point, I will hand over to Bastian.
So as Ari said, we start our lean application security approach usually with a kickoff workshop in order to understand the status quo on the customer side. So usually no customer starts at zero, but in most cases, there's something present, be it know-how, be it tools, be it some processes. So this is what we want to understand, and also the goals. So what is the driving factor for the customer? Probably there's a reason why they call us and ask for support. Being it a penetration test with a lot of findings, or being it requirements regarding compliance, for instance, adhering to some standard, or like OWASP, or in Germany is BSI, is for public sector, is obligatory. So this is something which we try and find out very early, so where we are and what the goal actually is, and what we can base on. In fact, what we want to achieve is a very tailored and efficient approach, because the gap between the status quo and the goals is actually what we need to implement and what we need to achieve. And this means we identify the required efforts to reach or to introduce as much security as necessary, and not as much security as possible. So this means that there cannot be any blueprint which fits for all, but instead we come up with a tailored approach which is as efficient as possible. So after identifying the goals where we want to go and some suitable intermediate steps and milestones to reach it, the next is the rollout phase. And this means for a company, for instance, which wants to improve the overall security level of our projects and all teams, they can decide whether they want to roll it out, a new process, the usage of new tools and stuff for first Lighthouse project, or in a broad range for all projects at the same time. And after rolling it out, the important point is to collect feedback and to take this feedback serious. It is very common that people are afraid of these new processes, that they feel uncomfortable because they're still lacking some knowledge. And this is where our contribution can ease the pain and make sure they understand all of this, and they get used to the new processes and tools and get familiar with it and feel comfortable, because in the end, they are developing secure products and don't need to be afraid anymore of incidents as they were beforehand. Finally, after concluding, we should reassess our status quo, which we achieved, and whether all requirements are fulfilled or whether there are any subsequent steps. In the course of this co-working with the customer and the introduction of processes and tools, there is a knowledge transfer happening. And this is something which stays a long time after we leave this company and the project. And this makes our approach very sustainable. So we support the customer with implementing all of this, with getting familiar with it and getting used to this. And this stays for a long time and makes our approach very sustainable. To give you a quick example how this might look like, we can consider a case where a customer approaches us and we agree on a 4 hours kickoff workshop in the beginning, and we identify as the most efficient effort to conduct a training and build up know-how in the team, and also to introduce a security champion to this software development team. In this case, we would first conduct the training, which is a very, very important effort. It brings knowledge to the whole team, which is actually a baseline for implementing secure software, because it's never possible as a one-man show. So you cannot introduce security saying the whole team does whatever it has done before, but only one guy now takes care of security and the rest doesn't care at all. This will never, ever work. So security is always a team effort. And this means we need to create know-how and awareness. And also what in our trainings happens is that the attendees will obtain the keywords which also the experts use. And this means they are able to understand the output of tools, but also to discuss with a security champion using the keywords of security. So this means after the training, the security champion would become a member of the team and understand himself as such a member. And this means he's not someone who checks is working which way and who introduces vulnerabilities. That's not the case. So what the security champion cares about is that the whole team together implements secure software. And in that role, the security champion usually works part-time in one project and can thus support several projects at the same time. One of the first steps is usually the identification of respective threats for this application that is being developed there. So the actual term is threat modeling, and this means to identify which threats apply and which ones are most crucial to mitigate. And as a next step, the security champion could come up with some mitigation approaches. And if there are several of those, they need to be evaluated in terms of the efforts for implementation, for maintenance, and the overall cost versus the protection effort which they achieve. And this could lead to a decision which of those approaches is finally being implemented. As a next step, the security champion might create some secure coding guidelines. So this means having like a cheat sheet to review whenever you do a peer-to-peer code review, or when you start working in the team to review, okay, what is the standard, the security standard the team is adhering to? How can I make sure that I implement secure software? And if you have such a coding guideline, which is targeted to the technologies used in this project, it means that you always have this as a cheat sheet while working in a daily life. This also brings some consciousness to the team and make sure that everyone is on the same page when talking about secure implementation. A security champion usually also introduces, if not ready, security check to the build and deployment pipeline. So some tools regularly double checking for vulnerabilities, and this thus giving feedback to the team. And whenever there's a team member having questions and being not sure what the relevance is of this current ticket he or she is working on, the security champion is ready to help and to support with all knowledge how this should be implemented. In the end, the team shall create a secure product, and this is the the actual achievement of the security champion. And this also comes along with the fact that after the planned finish of the development and a release of the software, there is usually no security fixing phase necessary. So we still recommend to make a service provider perform a penetration test, but in almost all cases there are no high or critical findings in those reports because the security champion took care of this beforehand. So this means when the product is about to go live, usually this can happen in time and doesn't need a dedicated vulnerability fixing phase. And this also reduces the cost, as we have seen in one of the first slides of Alvis, that the late fixing does not happen while most of the security vulnerabilities are fixed in the very beginning for lower cost. Yeah, talking about a know-how transfer and the necessary know-how for the whole team. So such trainings which provide know-how to this team are also part of our service. And we have different formats, and they are targeting different audiences. So one of the most common ones is the security best practices, where usually all, at least technical people of a project could attend. We also have trainings dedicated for developers, and even with the technologies they use, like Java and mobile platforms, and a dedicated training for QA testers as well, where we try and train testers to at least test the low-hanging security fruit. So what we cannot do is to make people a professional penetration tester within 2 or 3 days. This doesn't work actually, but explaining how attackers think and to explain what kind of test cases are appropriate to identify some security issues is a part of this training. And last but not least, it's very important that, for instance, in an agile team where a product owner determines the priority of tickets and the next effort for a sprint, it's important that also this product owner and the management he's reporting to has some security awareness in order to make sure that those tickets get the priority they need. We found that in such teams where the PO didn't have any security awareness, they gave very low priority to security tickets, and that way those tickets were created and could be implemented, but in fact they were delayed and postponed again because they had no priority. So in fact this would be a very bad situation because the application would still lack all the required security properties. And as we are very convinced that also seminars would transfer know-how to the audience should not be a theoretical approach, but instead should be a hands-on exercise which gives more fun and makes the learned know-how more sustainable. We also offer a lab environment. So actually, attendees can play the role of attackers there. This means we explain to them how vulnerabilities are occurring in the code, what they actually look like, how they can be identified and fixed. And afterwards, they can try themselves to identify vulnerabilities in our lab environment, where we introduce those in vulnerable applications, and they can try and find it and exploit it, and that way learn how an attacker thinks and works and what attackers actually see. And this has turned out to be a very helpful change of the point of view of those people. And afterwards, they look very differently on their own applications, meaning more from an attacker's point of view. This has turned out to be very helpful. Talking about hackers and testing and exploiting vulnerabilities. After all the proactive measures like coding guidelines, trainings, and a security expert, security champion in the team, what a team actually needs is some feedback. And this is usually provided by security testing. This means when a team has taken all the efforts to implement secure software, it definitely leads some feedback whether these efforts have been successful. And there are different categories of security tests. We have manual tests where a tester, a human, is performing the test either on a running application, then it's a dynamic test, and the classic pen test where a human is testing a running application. And we also have a manual code analysis, which we call static analysis. Static because there's no application running, but instead this person is analyzing code. This is helpful and appropriate for smaller pieces of code, like modules which implement cryptography, authentication, or authorization. And for large amount of code, those people should usually use a tool for analyzing the code, and combination of a human and a tool is also very fruitful in the end. So how does a penetration test actually work? A penetration tester, as we said and saw in the beginning with the castle or this ancient village, works or uses an application like every user. And this means that all the input that someone is creating and sending is sent through the firewall to the application and processed here. So what our pen testers on the application layer are trying is to find vulnerabilities in this application and not on some infrastructure and firewall level. And in order to find and identify this, one example is to find assumptions and break them, because there is a fundamental truth in security. This means every vulnerability is an assumption that breaks. And this means whenever there's a vulnerability out there, someone has taken some assumption, and someone else has been able to break it. In our case here, we consider, for instance, the first name and the last name of the user, which one might think and assume are characters and maybe some blanks and some hyphen. Like the phone number is numbers with a blank in between, maybe a plus in the beginning. Something like this is what this data usually looks like. The point here is we have learned in our life that this is how this data looks like, but there is actually no enforcement that in these data fields, the application only receives such data. And this is one of the very classic vulnerabilities we find in our penetration tests, that some crafted data causes errors on the server side while processing it. And in some cases, these errors actually lead to, for instance, the option for the attacker to execute code in the back end or in the front end of other users. There are different cases and different categories of vulnerabilities and exploits. But in fact, the input that you see here is classic attack patterns, which try to exploit different categories of vulnerabilities. And what they all have in common is they look completely different from what one expects to see in these data fields. And as long as an application can handle and treat all of these kinds of inputs, it's secure. And vice versa, as long as there's at least one input field which is not processed appropriately, there is a vulnerability. Being it exploitable or not is then another story, but this is what pen testers are actually looking for. Okay, having said this, there is another very common assumption that we break in almost all pen tests, and this is for mobile tests. So, as I said, one might assume that a username or a user's name might only consist of literals with a blank in between. And as a mobile developer, I might assume, okay, I have this device here, and in my app, I coded the checkout that this input only consists of these literals and a blank. And then I have an encrypted channel towards my application, and there I can assume that it's still only the input I checked in the app already. So there's no need to check again in the backend. This assumption is breakable because in our penetration tests, we can still open this encrypted channel and replace the input by something else that we decide on. And in this case that I described, the backend would not be prepared for this and probably have a vulnerability that is exploitable this way. So why does this assumption here break such easily? Because it only holds when the device here is not compromised. But if this is my device, my attacker's device, I can compromise this myself and that way open this channel. So this is why it's an assumption we can break in an attack scenario. Whenever we find such cases, such assumptions that break, and we identify a vulnerability, we report on this in the final penetration test report. So this means for each such behavior of the application we find, we describe the test case, what we observed, why this is a problem, what an attacker could do with it, and recommendations how to fix it. But we also describe the test cases where we found actually nothing. So we tried this and this and this and this, but actually we haven't found any security issues during these tests. This is also helpful for customers in order to know which of these security tests have been conducted without any find. Also, it is very common in the penetration testing business to send the report as a static PDF file. However, we know that many of our customers want to process those findings and forward them to different teams taking care of this. For instance, we could also identify vulnerabilities on the encryption layer of HTTPS. This goes to the operating team, while classic application layer vulnerabilities, like the ones I showed you, where I have some crafted input, they go to the development team, and there might be even more vulnerabilities. So for these reasons, we provide our report in different formats that can be processed on the customer side. And one of these is also an HTML file, which can be submitted as easily as the PDF, but it's not static, it's dynamic. So you have an HTML file and you can search, you can filter. There are different categories and different features of each vulnerability, which you can consider separately. And this is something more interactive and easier to work with. So overall, we are looking back to more than 15, almost 20 years of penetration testing. And we summed up all our lessons learned for our customers in a white paper, which we call our Pentest FAQ. And this is freely available on our website for download. And it explains to customers what they need to provide to let us do a penetration test, which environments like user accounts, stuff like this, why this is necessary. And they also learn what they can expect from us as a result, and how to treat and when to perform a penetration test back. In fact, for instance, in agile development scenarios, it makes no sense to perform a penetration test after each sprint, like every 2 weeks. But in fact, you want to have a feedback and a security check at least in each sprint, maybe even more often, like every night or every week. So for this, there will be automatic tests. And one of the automatic tests is static code analysis, which can be done by tools. You can use static code analysis also by humans, which use the tool and analyze the findings immediately and use this as a gateway test and only release new software when there are no or almost no open issues anymore. But you can also use such tools for automatic security testing. And if you use like a static code analysis tool plus a software composition analysis tool and dynamic analysis, so there are different classes of tools which you usually want to combine in order to get a good coverage of tests for your software. And in order to do this and run this automatically, you need to configure and integrate those tools to your build pipeline. This is something that our security champions regularly do. So they set it up and they configure it appropriately for the project, and they make sure that the team knows how to run and how to interpret the results. So this is a very common task for us. In order to make lives a bit easier and decrease the amount of work which is necessary to do this in each and every project, again, in our house, we implemented a platform which is called Atlas, and which unifies those tools and actually abstracts from those. So in this case, we have a build and deployment pipeline being run by a CI tool. And from there, this CI tool can trigger a security scan using our platform Atlas. And this platform takes care that the respective tools can run and trigger the scan that has been asked for by the project which triggered the scan. And those tools start running and analyzing the application and all its content and the code and the configuration. And after being finished, Atlas collects back all the results in all different formats and harmonizes them and reports back to the CI tool the severities that it found. So for instance, found 2 high findings and 1 medium finding. And then the project can decide whether to create an alarm, for instance, or to make the build break, and how to treat this result. But that's not all of. Obviously, those issues need to be fixed then. And this is where the management interface comes into play. So the users of Atlas have a dashboard at hand and can review the identified issues there. So this means they can get all the details from those security findings. They can reclassify the severity if necessary. They can add some comments to developers, for instance, that the security champion says, okay, this can be fixed this and this and this way. And this is what happens, the actual work in the dashboard before running the scan again, and then hopefully having no findings anymore. So the dashboard actually looks a bit like this one here on the left-hand side, where you have all the numbers on critical findings and high findings and medium and low findings, some graphs, and here some tables. You can filter your findings, and the hierarchy is actually for each project being maintained by Atlas can have several products. So like microservice architecture, you can have each service as a product. And you can, when you run a number of tools at the same time, they all together are one engagement, and each of these tools being run is a scan, and each scan can have several security findings. So this is the hierarchy and how you can manage all your security findings from those tools. There is another feature in Atlas, and this is called those components. And this is actually targeting third-party software components. And you get in Atlas an overview of the components you have in your technology stack and the third-party open source components. And this is for the reason that in the past years, the topic of supply chain security has been very common in the security community, and we identified a couple of severe issues in this field. So this means when projects, and this is a very ongoing trend, tend to involve more and more third-party open source libraries and frameworks, those even pull more transitive dependencies. So this means in the technology stack of a project, there are a couple of software modules which have not been developed by the team itself, but by a third-party community. And this way, this code has become part of the project supply chain. And the problem is that you usually don't know the developers being responsible, or the community being responsible for this. And by not knowing them, it means you usually cannot trust them completely. So those components might contain malicious code, which we have seen in the past several times. So this code stealing credentials or stealing computing cycles and computing some bitcoins. But they may also contain vulnerabilities. So this is not intended to be, but it happens from time to time. And as a professional attacker, knowing that some of those components, libraries and frameworks, are very common out there, and there are millions of projects using it, those attackers only need to track and observe whether there's a new vulnerability being reported and being common, and then preparing an exploit for this and immediately targeting all applications and trying to exploit this vulnerability in this very common open source component. So this means with very little effort, the attackers have the chance to exploit thousands or even millions of applications. And finally, there is a compliance issue because those libraries, even though they are being released under some open source license, those licenses differ. And depending on the license, they come with different obligations for the user of this library, and this needs to be known by the software vendor. So our approach to mitigate the supply chain security topic is to create so-called software bill of material. This means like a list of third-party dependencies, including the transitive ones. And with this list, there are two standard formats to express those lists. And those formats can be consumed by tools. And those tools finally sync this list with a public database of known vulnerabilities. So this means when we prepare such an inventory, such an SBOM, we have a tool which can compare the existing libraries with their versions, and this database saying, okay, this library in this version has this vulnerability, and with a match, we get a report, and then we know which libraries we need to update in order to fix the vulnerability. Also, those tools are able to match the libraries with their open source licenses and create an alarm whenever there is a mismatch in the licenses we use. So to sum up, our approach, which we call lean application security, can support projects or even companies and raise security there. And we usually support projects also with integrating DevSecOps, so security tools in the pipelines. This is a very common request these days. Whenever necessary, we provide seminars for know-how transfer and making sure that the whole team is aware and has all the knowledge to write secure software. And as a feedback and as a double checking point, we also provide manual and automatic testing for customers in order to make sure that each project gets the feedback and the go live as a gatekeeper if necessary by Pentest. So thank you very much.